Hi, welcome. In this video, we'll solve problem threesome asked by companies like Amazon, Microsoft, Facebook, etc. Now let's check out this problem. This is the most famous problem, threesome. Okay. So given an integer array nums, so we have one array nums and written all the triplets. So here you can see these are the triplets. Okay, nums of I, nums of j, and nums of k are the triplets such that I should not equals to j, I should not equals to k, j should not equals to k. Okay, and the nums of I plus nums of j plus nums of k should be equals to 0. So that is the condition. Note that the solution set must not contain any duplicate triplets. So there should not be any duplicate triplets. Okay, now let's quickly understand the examples one by one. So here you can see in this example we have -1 0 1 2 -1 -4. So let me quickly write the indexes 0 1 2 3 4 5. So what is the meaning of I should not equals to j and I should not equals to k and j should not equals to k? That means all these three indexes should be different. Okay, there should not be same index. Okay, so that means you can't take -1 twice. Okay, so like you are saying, so one of the triplet you are saying, suppose mentioning -1 0 1, or suppose again you are taking some -1 and you are taking the same 0. Okay, and then you are taking some other plus. Okay, so that is present something like this, like here you can see 0 1 and -1. So if I am creating one more triplet 0 1 -1, that is also a same triplet. The main thing is I should not equals to j, should not equals to k. That means all the three indexes should be different. There can be same elements, right? -1 can be 3 times, 3 to 4, any number of times. Okay, so there can be same elements, but the indexes here you can see all the indexes will be different. Okay, so this is the thing, that all the elements should be present, right? You can't take the same element twice. Okay, so here by this condition, not take the same element twice. Okay, okay. Now first this condition is done. Now the second condition is nums of I plus nums of j plus nums of k should be equals to 0. So basically the nums of I plus nums of j and plus nums of k should be equals to 0. So that means I want is like -1 is one example, plus 0 and plus 1, right? So if I simply sum it, it will give me 0. So that is one possible triplet, -1 0 and 1. If I check out any other triplet, so if you can see here, you are getting one -1. Okay, and this -1. Okay, again this different element, these two are different elements, so I can take it -1 -1 and 2. Okay, so this is the second triplet, and let me check is there any other triplet. So if I am taking 0 comma 1 comma -1, that is also one possible triplet, right? 0 1 -1. Okay, but if you see this is exactly like the previous triplet, right? -1 0 1. So in the triplet we have the same elements, right? More or less same. Basically they have sorted and they in a different direction, they have sorted in a different direction. But both the elements in the triplet are same. Okay. So here we are not following this condition. Like our solution must not contain any duplicate triplets. So that's a duplicate triplet. That's a duplicate triplet. So we know we don't need to count this triplet, so this won't be there. Okay, so there will be only two triplets and these are the two triplets. Okay, suppose instead of -1, or like here instead of this -1 we have only single -1. Suppose here we don't have this -1, we have only single -1. So you can't take something like this -1 -1 and 2. So you are actually taking -1 two times to make it 0. Okay, that is not correct. Again, it's not following this condition. So I hope this is clear to you how we are going to take triplets. So basically we need to find A plus B plus C, 3 elements. Their sum should be equals to 0, and these 3 elements indexes should be different. If I say in a simple and clearer way, so this is our goal. So here you can see we have only 3 elements. So 0 plus 1 won't make it 0. So there is no triplets. There is no possible triplets, right? So that's why it is empty. And for these elements here, we won't get no triplets. Now let's see how we can solve this question. So I have this nums, and if I go with the one of the approach that is coming to my mind, okay, that will be the first approach, and I will call it as the brute force approach. Okay, and always during the interview you should always first explain the brute force approach. Okay, because this is the most common, or this will also think help interviewer that you are thinking, okay, there's something running in your mind, okay, you are coming with some solutions. So this is very good to come up with a brute force solution first. So if I take the brute force solution first, okay, what things, how can I solve this question basically? So I will take this first element, okay, and then in the rest of the elements, okay, I will check my 2 elements. Okay, so I will first take the first element, I will make it constant, and for the rest of the elements I will find the 2 elements. And what I will do here again, I will take the second element, suppose this one, okay, and then in the rest of the elements I will find the third element. By this way we can find the 3 elements. So what I'm saying, I'm just saying to apply 3 loops basically here, that we will take first loop that will start from 0 to n, and then second loop will start from j to n, and the third loop will start from like k to n, like here. Okay, so this is how we can proceed it. So let me tell you how I'm just basically I'm giving you more visualization of my approach. Okay, so suppose I am taking one for loop and it will start from 0 to n. Okay, this is one for loop, and I will decide that suppose this is my first element. So I have fixed it. Okay, now the next 2 elements I will search it here. So again I will take one for loop. Okay, that will start from j I plus 1. Okay, why I plus 1? Because this is already taken, right? We are not going to take it again. Okay, so it will start from j I plus 1 to n, and then again let me put it this something like here, and then again I will take one for loop that will start from k is equal to j plus 1 to n. Again this is a pseudo code. Okay, and now we will check the condition. So here we will check the condition if a r or phi, suppose this is array, or here I'm taking nums, so let's take nums. So nums of I plus nums of j plus nums of k, if, okay, if this is going to be 0, okay, what we will say, we will say that here we have found the our element, okay, our triplets. Basically here we have find the triplets. Now here suppose if this condition is true, we will come inside and we will take one triplet, and triplet will be our again nums of I am writing as n of I, n of j, and n of k. Okay, now we also need to check it should not be duplicate, right? Suppose like here if you are going in this direction, you will find 1 minus 1 0 comma 1, and again like by one condition you will find 0 1 comma minus 1. Okay, and these both are same, these both are same, right? So what we will do, we will simply, to find out that these both are same, how the program will get to know, what we will do, we will sort it. Okay, so if I sort it, the first one will be minus 1 0 1. Okay, same, and the second one will also become minus 1 0 comma plus. Okay, so now these will be two same, and now we can simply store the triplet in our hash map objects. Okay, you can take, so in JavaScript I will take object, so I will basically store in object, suppose I am storing in the object triplet. Okay, and I will check like if object of triplet is defined. Okay, so if it is already defined, right, I won't do anything. If it is not defined, then I will simply define it. Okay, so if it is not defined, let me put this not equals to. If it is not defined, I will basically define it. Okay, and once I defined it, in my objects all these elements will be present. Okay, and now to present our answer. Okay, now because there should be an answer, right? So to present my answer, what I will do, I will define in the object, as well as I will create one answer array, and I will basically push into my answer array. Okay, I will push that triplet to my answer array. Okay, so in the final outcome, I will get the complete triplets. So let's quickly, I will give you a quick demo of it. Okay, so how we are going to do it. So suppose my ith loop is starting from 0 to n. So this is my I. Okay, my j will start from I plus 1 to n. So my this will be my jth element, and my k will start from j plus 1 to n. So my this will be the kth element, and let me remove this line. So my kth element will be from here. Okay, I will check if this is the triplet. Is my nums of I plus nums of j nums of k is equals to 0? Yes, this is 0. So what I will do, I will simply store this triplet here, like -1 comma 0 comma 1, and I will check. I will create one object. Is this is present in my object? Okay, so suppose this is my object. Okay, key value pairs basically, and let me quickly create this one. So I will basically here, I will check, is it present in my object? No, it is not. So I will simply make it in my object. Okay, that is a key value pair. And once I defined it here, what I will do, I will also push in my answer array. So in my answer array, I will push it. So it will -1 0 comma 1. Okay. Now again, you are in the third loop. Okay, so this key will move, and it will check, is -1 0 comma 2, is it making 0? No. Okay, again you will move your k pointer. Is -1 0 comma -1 is making it 0? No. Okay, you again move it. Now -1 comma 0 comma -4, is it making the total sum as 0? No, again. So here your kth loop is exhausted. Now you will come to here, you will do j plus plus, right? So now from j will come to here. Okay, j will come to here. And again your k will start from here, right? J plus 1, k will start from j plus 1. So -1 plus 1 comma 2, is it making 0? No. Again, is -1 1 -1, is it making 0? No. Okay, now again, is -1 1 comma -4, is it making 0? No. Again, so by this you can simply understand, in the same fashion we will simply solve this question. And yes, we will able to solve it, but the time complexity will be very large. Here you are using 3 loops, so the time complexity will be of let me check. So first of all, I am taking n cube. Why? Because I am taking 3 loops. Inside n cube, I am doing a bit of sorting, right? So here we are sorting as well, right? We are sorting to basically sort it so that we will get if these are equal or not. So, but there are only 3 triplets, like, okay. So it will be like, even I am taking n log n, okay. Okay, it won't take too much time because, okay, 3 elements are there, right? Only one triplet. So 3 element sorting won't take too much time. So I am ignoring this sorting. Okay, and then we are simply using object in space. So if I talk about the space complexity here, we are using one object, and we are using an answer array. Okay, that will store, that is going to be store n elements, right? So it is around 2n, which is again big O of n, order of n only. And the time complexity will be big O of n cube. Again, remember that we have ignored the sorting time complexity because these are going to be taking only 3 elements. Okay. So here the time complexity of this approach is big O of n cube, and the space complexity is big O of n. Okay. But this is the first approach that comes to your mind, that is a brute force approach. Now let's see how we can optimize this problem. If I'm going to optimize it, so I will consider approach 2. Okay. And let's see what is the, again understand the problem statement, and again let's see how we can come up with an optimized approach. So the goal of this question, again, let me clear this. I should not equals to j, and these three should not equals. That means three different elements. You can't take the same element twice. And a plus b plus c should be equals to 0. Okay. This is the goal of this question. Okay, a plus b plus c equals to 0. And where we were taking time, we are going with n cube. We are taking three elements one by one, one by one. Okay, and we were taking some spaces. So if I try, can I write b plus c equals to minus a? Yes, I can write. And can I write b plus c equals to k? Basically, I am saying k equals to minus a, right? Now, are you getting any hunch here? B plus C equals to minus A, right? We have solved these types of problems, right? If you can remember two pointers, right? So by by two pointer approach, we can solve this. Basically, we need to find two pointers to have the value, the sum to target sum K, right? So if you remember the same problem, that is two sum. Okay, so where you have two pointers L and R that will eventually come give to the target sum K. Okay, you will find the target sum K. So yes, in the next approach, in the approach 2, we will try to solve this by two pointer approach. Okay, so let's see how we can solve this with the two pointer approach. So what I will do, I will try, I will again take one element. Okay, and let's suppose I am taking the first element as A. Okay, I am considering this as an A, and the rest of the two elements I will try to find it here. Okay, I will try to find in the left the array which is remaining, right? So I will take two pointers here. So my one pointer will be L here, one pointer R will be here. Okay, so now your A will move again. So one time it will be constant, but it will move eventually. Okay, and so as your L pointer will also move. Okay, so if I am consider A, you can consider A, or you can consider with I. Let's suppose I, so that it will make a better sense. So if your I is 0, what will be your L pointer? Again I plus 1. If your I is 1, what will be your L pointer? So I plus 1, L will be at 1. Then again I plus 1, it will be 2. Then if your pointer I pointer is 2, it will be again I plus 1, so it will be 3, right? So your L pointer will move eventually, but your R pointer is going to be same, that is n minus 1. In all these three conditions, your R pointer is going to be same, that is n minus 1, right? It will be always same. So let me give you a quick idea how I am telling this. So basically I will take this first element and I will apply two pointer here, right? So my L pointer will be here, R pointer will be here. Now suppose I am taking the second element here, okay? And now then I will apply the two pointer here. So my L pointer will here, R pointer will here, okay? So you can say like this is your A, okay? Now this is your A. Now suppose here if I am taking this third element as here, I am will apply the two pointer here in the rest of the elements. So this will be L, this will be R. If I'm taking this element as A, okay, I will apply the two pointer here. Okay, so you can see, right, your L pointer always coming one side with A, right, with A, right. So if it is 0, it will be I plus 1. 1, if it is 1, it will be 2, it will, if it is 2, it will be 3. But your R pointer is completely constant. Okay, your R pointer will always be same. Clear? Yes. So we will try to solve this question by this thing. So again, what we will do, we will understand this by, let me quickly copy this. So we will take three elements, right? So I will start with one for loop, okay, that will start again from 0 to n, and that will basically for my A element, right? So if I am saying A plus B plus C, I am considering ith pointer will be for my ith element. Okay. And now for the next of the things, for next of the set, what I will do, I will apply the two pointers. Okay. So I will take L pointer as I plus 1. and our pointer will always be n minus 1. Okay, this is capital N, so let me add this to be capital N minus 1, and I will put simply while L is less than R. Basically simple two pointer approach. I will put while L is less than R. I will check for this condition if A plus B plus C. So you can simply say that nums of I plus nums of J plus nums of K, if it is equals to 0, right? So what I will do, again we will do the same condition, right? If it is now equals to 0, we will again check, right, the triplet. Okay, and we will check if what is the triplet. My triplet will be n of I, n of j, and n of k. Okay, again what we will do, as we have done, we don't need any duplicates here. So what I will do, I will sort the triplet. I will basically sort my triplet, and after sorting, again I will check if my triplet, okay, is present in the object. So I will check if my triplet is present in the object. Okay, so what I will do, I will define that triplet equals to 1, as well as after defining, what I will do, I will store in my array. Basically I will do the same. I will store in the array to simply print the answer. Okay, so now you can see here we will get the same result, but the time complexity will be changed here, right? So here I am taking this loop, okay, right? So it will constitute n, and inside this I am taking one while loop that will also take n time. Okay, it will n time. So here the time complexity will be around n square. Okay, and again the time will be of sorting, right? So if you are taking sorting triplet again and again, okay, so here you can simply mention that timing, right? So again there is a time of there is a triplet, right? So there are three elements only. Okay, so again whatever the time will be, like m log m you can say, okay, will constitute to this n square. Okay, and after this the time complexity, this n square m log m, okay, the space complexity will be remains same, right? Again it will be big of n, you are taking object, again you are taking an object, and you are taking an answer array to present the answer. Okay, so is there any better way for it? Okay, so let's see what are the things that we are doing in our this approach 2 with the two pointers, how we can optimize it. So you can see one of the thing that we are sorting it, right? Again and again we will sort it, right? So if there are n square, I need to sort it the triplet n times, right? N square times. Okay, again these three elements n square times. So why I am getting this minus 1 0 1, and one of the triplet I am getting 0 1 and minus 1, right? This is the issue, right? I'm getting these two different triplets, and I need to sort it so that my program will get to know that these are two the same triplets. Okay, so what I will do from in the beginning, what I will do, okay, I will sort my array, right? So instead of sorting at the last the triplet, what I will do, I will sort it here itself. So if I am sorting here, if I am sorting here, it will be minus 1. Let's minus 4 first, then minus 1, then minus 1, then it will be 0, then 1 and 2. Okay. Now if I am finding a triplet from this sorted array, okay, what I will get? I will get minus 1, okay, then 0, then 1. And if even if I am taking this minus 1, I will get the same triplet minus 0 and 1. Right? So even if I'm taking this one, and this one, I am getting the same triplet, and minus 1, 0, comma 1. Again, I am getting the same triplet. So if you have sorted before, if you have sorted here itself before going to the loop, if you sorted the array, you can, there is no need to sort it here. Okay. So basically you can optimize it. So let me put in approach 3. So give me just a minute. So I forgot to mention here, even we are applying two pointer approach, right? We are applying two pointer approach. So we need to do sorting beforehand. only, because there won't be possible to apply two-pointer approach, right? The array should be sorted, because how you will get to know that you need to increase or decrease, right? So this step won't be there, right? This step won't be there. We need to do sorting first beforehand, right? So I need to sort the array. I need to sort the array and then I need to apply it. So it won't be of m log n, it will be of n square plus, you can say, it will take n log n. And again, we will take the higher term. So this will be big of n square only. So the time complexity, which is going to be big of n square, and space complexity will be big of n, right? We are storing in an object, we are checking it. Okay. So we need to sort it beforehand, because if you are sorting beforehand, then you will be able to apply the two-pointer approach, right? You can't apply it here. Okay. And this will also reduce your like duplicate triplets. Now let's see, is there any better version of it, right? We are almost close to our solution. Okay. Is there any better version of it? So what we can do here, so let's try the same approach. Okay. That is two-pointer approach, but can we see some repetition there? Okay. Two-pointer approach. Let's see. Can we see some repetition here? So let me quickly copy it. So we were solving it. Okay. So we came up with the two-pointer approach, but let's take some edge cases here, right? So that we can better optimize our solution. Let's take some of the edge cases here. So what I'm saying, that you are getting the triplets, that's fine. But suppose if there is a repeated elements, right? Repeated triplets, if I say, how you can understand it? It's like suppose you have 0, 0, 0, like everywhere is 0. This many 0. Okay. So if you have this many zeros, okay. And so what will be the answer of this question? Like if I simply make it this one example, what will the answer of it? There will be only one triplet, right? 0, comma 0, comma 0, right? This will be the answer. But by the approach, the previous approach, okay, by the previous approach, we will get this answer, but it will be repetitive. It will again check it, right? So suppose it will first check these three elements, 0, comma 0, comma 0, okay. And after my, again, both pointer will move, okay. Again, they will check for the possibilities. They will check for the possibilities. Can this be one of the solution? They will check in the object. And once they will put in the object, then they will get to know, okay, this is repeated. Okay, so we don't need to take it. So in the previous code, you can see my this L pointer and L and R pointer both will move. Both will move. Okay. But in the object, we will get to know that we don't need to take it, right? We don't need to take it. This is already taken. This is already taken. Right. So we can further optimize the answer. We can further optimize the answer. So how we can optimize it? So suppose let's consider the same example. If I am taking this one example, okay, and I have this much zeros. So what I will do, again, I will take one pointer here, that is I pointer, and I will look for L pointer and R pointer. Okay, this for L and R, and array is already sorted beforehand. Array is already sorted, that is nums array. Okay. So this is my nums. So what I will do, I will check L and R. I will check L and R, and I will check here. Key okay. This is one of the solution. I will get one solution 0, comma 0, comma 0. Okay. And now what will happen? Basically, once you get a solution, you will move your first L pointer and R pointer, right? Both the pointer, because you got the solution. You are not taking these elements. But you need to check, is it the same element that the previous one? Is it the same element with the last one? Yes. So I'm not going to take it, because this will create the same element. This will create the same element, right? So I am not going to take it. Let's move forward, right? So you will move your L pointer again. You will move your R pointer again. Okay. Is it the same element as the previous one? Yes. Is it the same element with the previous one? Yes. So what you will do? You will move your L pointer again. You will move your R pointer again. Is it the same element as the previous? Yes. You will move it. If is it the same element with the previous? Yes, you will move it. And again you will move it. And now here you can see R is greater than L. So this will stop the condition and you will be able to find the answer, right? So you will get the answer. So here you can see we are not checking in the object. We are not checking in the object or hash map. that is it duplicate or not. We are directly checking it that this is the same element that we have taken before. Yes, it is. So we are not going to take it. Okay. So this one optimization we can do in our approach. So let me tell you. Let me give you one example. Okay. So let's check out this example. Okay. So I am taking this first element. This is my ith element. Okay. And I am taking this L pointer or this R pointer. Okay. And I'm checking is this element is making 0. So A plus B plus C, is this going to be 0? So I will take first -3, and L is also pointing to -3, and R is also R is pointing to +3. So what will be the total sum? Okay, the sum will become -3. Okay, which is less than your 0, right? Which is less than your 0. So what do you want? You want to increase the sum. You want the sum should be increased, right? So how it will increase? You will move your L pointer. Okay, so you will move your L pointer. Again you will check, okay, what is the sum? So now the sum is, let me quickly delete this, and now the sum again the same, -3, then -3, then +3. Again the sum is same, right? So again the sum is same, -3, right? So we again will move forward. We again will move forward with the L pointer. Try like if we are getting better solution. So again -3, +3. Again the sum is -3, no change. So we will again move forward. And now we will check. So we have the sum -3, -1, and +3. So now this is -1. Yeah, it a bit improved, but still less than 0, right? We want 0 completely, so we will again move, right? I will again move, again same -L, so I will again move, okay? Again same -L, I will again move, and now I am getting 0 here. So now let's quickly check the sum, -3 plus 0 plus 3, okay? Your R pointer, and now you are getting the sum equals to 0. Okay, so this is one of your solution. This is one of your solution. Okay, so you will simply store it in your answer. You will simply store it in your answer. -3 is 0 comma +3. Okay, and you will simply store your answer, and then you will move both the pointer. You will move both the pointer, L plus plus and then R minus minus, L plus plus and R minus minus. Okay, and after moving my both the pointers, my pointers will be lie here. Okay, now what I will do, I will check, okay, that my L pointer is here at 8th position. My R pointer is at here, 14th position. And this is exactly the same that we have created, right? My L pointer were in the answer. This is exactly the same as the previous one. This is also exactly the same as the previous one. So what we will do, we will move forward, move forward. Okay, so I will move L pointer again the same. Let's move. Okay, so now this is the different. Again, R pointer is same. I will move it again here as well. R pointer is same. So what I will do, I will move it. Okay. Now once I moved it, I get a different things, right? So now I am getting -3 and +1 and again +1. So this is going to be a -1, which is again less than 0. So what we will do, we will move L pointer. We will move L pointer to increase the sum. Okay, but still I am getting the same sum. Again, I will move L pointer. Again, I am getting the same sum, and now both the pointer, both R and L pointer pointing to the same index. R is also 12, L is also 12, right? So here my loop will terminate, and I will eventually get a solution of -3 comma 0 comma +3, right? This is one of the solution. Okay, this is one of the solution. But again, this is not the only solution. Here, how many solution we will get? We will get one solution as -3 comma 0 comma +3, and we will get one solution as -1 comma 0 comma +1. Okay, so how we will get that solution? Okay, so we have this -3, right? Now once we get the -3, I will change my I pointer. If you can see, my I pointer was same, right? Now it's time to change the ith pointer, right? So I will change my I pointer. But again here as well, I will check, is it the previous one? Is it the previous one? So I will move my I pointer. Okay, is it the previous one? Yes, I will move it. Okay, is it the previous one? Yes, I will move it. And now my I pointer will be here, right, at -1. So now my I pointer, it's pointing to -1 here. Okay. And now from here, I will create my L pointer, right? So from here, I will create my L pointer. So L pointer will start from 5th index. Okay. So I will get minus 1, and my R pointer will always start from the last index again. My R pointer will start from plus 3, and I am getting again plus 1 as an answer. Okay, I am getting plus 1 as an answer. So here I am getting plus 1, which is greater than 0. So I will say decrease it, decrease the sum. So I will move my R pointer. Okay, I will move my R pointer. So I will move my R pointer, right? So here this is my R pointer. Again, the same sum will be same. I will move my R pointer. Again, the sum will be same. I will move my R pointer. Now here I am getting a sum of minus 1. I pointer is pointing to minus 1. L pointer is pointing to minus 1. And R pointing is pointing to plus 1. Okay, what is the change? What is the difference? So now I am getting minus 2. Okay, no, sorry, not minus 2. I am getting minus 1, which is again less than 0. Okay, let's quickly remove this to create, because this is creating confusion. So my pointer, my ith pointer is in the first minus 1 here. My L pointer was here. Okay, and my R pointer is shifted to here. Okay, and now what I am getting the sum? I am getting sum again minus 1, right? Minus 1 plus 1. Okay, again not an answer. So what I will do, I will increase it. So for increase it, what I will do, I will move my L pointer. Okay, again no difference, same thing, right? Again I will move my L pointer, right? So now what will be the sum? Minus 1 plus 0 plus 1. Okay, and that is your 0, right? So what you will do, you will add that answer. You will add that answer here. Okay, and now once you add it, you will move your L pointer. Okay, and you will move your R pointer. Now you are again checking, is your L pointer is same as the previous one that you have used? Yes, it was 0, right? So we will move it. We will move it. You will move it again. L point. Okay, again same, you will move it again. R is also same, you will move it R. R is again same, you will move it R. And again here, R is greater than L. Okay, so that is a stopping condition. You will stop here. Okay, you will stop here, and once you stopped it, again your I pointer will move. But here you can see I is also checking, like this is same as the previous one, so it will also move. It will also move, and eventually we will get this as in solution, right? So we will, by this we don't need to check on the hash map, right? We don't need to check on the hash map. Okay, we can directly give the answer. Even still the time complexity will be same, right? For approach 3, the time complexity will be same, because again you will take one loop for ith element, right? You will take one loop for ith element, and you will take while loop for L and R. So time complexity will be big of n square. Okay, and this is the maximum part, because I'm not considering the sorting, because sorting will take n log n. So if I take the which will take more time than n log n and big of n square, so n square will take more time. Okay, now about the space complexity. Space complexity will be big of n, because you are taking an answer array. Just because of answer array, because you need to print the output in the answer array. That's why the time complexity, space complexity is big of n. Otherwise, like you have simply removed the object hash map thing, right? So from here, there won't be use of any object, right? You can, because we are already checking here, like, is it the previous one? Is it the previous one? Is it the previous one? And if it is, we are simply moving forward. Okay. So again, here the time complexity of the approach 3 will be big of n square, and space complexity will be big of n. So now in the next video, you will get to know about the code implementation part of it. Okay. So you will, well, let's check out the how we can apply all the last approach, okay, that we have concluded in our code.